Alright, so now let's continue on to question 4, and this one states a rectangle with vertices 621, negative 147, 206, and 563, 31, 242, and 657, negative 111, and 86, and the last point 599, 67, 122 is added to the scene, and the line intersects this rectangle. So if you have a rectangle like this, and it goes through it, and to make the rectangle appear opaque, in other words, not transparent, in other words, you can't see the line behind it, where it's behind it, a programmer can use a hidden line rendering, which removes the portions of the objects that are behind other objects. So basically, we remove this section here, as opposed to drawing a line straight through it. Yeah, as opposed to going straight through, like that. And yeah, so it removes the objects behind other objects. And now we're asked, identify the portion of L that should be removed. And in this case, again, so you're going to have to remove this portion right there. So let's take a look at the solution. So let's graph out the rectangle inside GeoGebra, as well as its projection onto the screen. All right, so recall the equation for the projection from 3D to 2D. And yeah, we could scroll over to that equation that we set up. And that's just right here. So we have the projection z or y prime equals to z or x, z or y divided by 1 minus x over 1,000. So we project it on there, and let's go and write that down. So here's the calculations. So for the first point, 621, negative 147, and 206, we project that. So this is the rectangle, and this is the projection. So we go 0, this was 621 becomes 0. So this projects to 0. Then we'll have this negative 147 divided by 1 minus 621 is the x, divided by 1,000, and then plug this into the calculator. This equals 2. Yeah, so this is our built-in calculator, negative 387.86, and that's this number right here. And then over here, then the next one is the Z1, 206 maps to 1, and then you're going to go 206 divided by 1 minus 621 divided by 1,000, and we're going to get this number. All right, so we get that 543.53 round up to 54. So this is the point, and do that the same thing for the next 3 coordinates. So this is the rectangle, it's 563. This maps onto over here 0, 70.94, 55, 3.78. And again, you always have to use a different x. So this x goes in there. The 657 is for this one, and so on. So this 657 negative 111. That's this right here. And then the next one, 599, etc. 599, 67, 122. So you plug that in, you get these values. And then if you graph the GeoGebra, so what you could do is, well, you could just type rectangle. And actually what I did was, yeah, first I wrote the rectangle 1, 621, negative 147, and 206, and etc. Put in those coordinates for the rectangle. And then you draw the polygon with the rectangle as the points. And then I'll do the projection here. This is the projection 0, negative 387.86, and then 543.54. That's just this projection. The next projection 2 is this one right here, 70.94. That's just this right here. So anyways, so I plug in those projections, and then I do then I create a segment. Actually, no, I don't create it. These are auto-created by GeoGebra for some reason. These ones, I just go into here and create a polygon. So projection R1, projection R3, and then R4, R2. And I made sure this is in order, because otherwise you're going to have a different cross-section. Yeah, what I mean by this, I made sure it's a rectangle, otherwise you would have had something that looks like this. If this is the point, you go here. And then if you do it out of order, so I made sure that I had to rearrange it so that it looks like a rectangle. So you do it in order, like that, as opposed to a star or some random shape it gets. And then I also have a sight line checking here, and you can change this R1 here, and you can draw a line through here, etc., and see if it's just to double check the work. So we'll do that. I'm going to lower this. All right. All right, so here we get to the GeoGebra. Let's move this around. So there's what we have. So there's the rectangle. Let's go back here. So there's the rectangle here. Let's zoom it out and move this around. Yeah, so we have the line. It penetrates through the rectangle like that. So it goes through it. And then if you project on a screen, so it looks like that. But again, we want to make the rectangle opaque, so that we have to clip this from here. From here, into the point wherever it's being projected out. So it's going to be somewhere around here. So what this means is we have to look at the point that it goes through this. Yeah, so it's going to be somewhere around this point here, somewhere around here. So we have to find the intersection of the line to that point. And then here's a sight line checking here, just to make sure that we're going through. So this point goes through here, it goes through there, and this segment is just from the camera to the projection R1. So if we do R2, it should connect through the second point. Yeah, so there it is. It connects straight to this one here. So I'm not drawing it from here to here. I'm drawing it from here, the camera, all the way to here. But it cuts through that. Let's do a couple more. Sight line checking, and then this one here, 3. So there it is. It cuts through the bottom. Then last one, 4, just to double check. All right, there it is. And it connects from here. So all this is from projection. This one is actually just from the camera up to projection R4. So from here to here, and it connects through here. And that is a double check that we got it right. Anyway, so that is what we have. So we have to clip out that segment. All right, let's continue further. So yes, epic stuff here. All right, so let's see what we were asked. So we were asked to remove the portion of the line behind the rectangle that is projected onto the screen. So if you look at it here, we have to get the parts beyond the rectangle, and that's going to be somewhere around here. So in other words, this part here, so from there to here, we need to clip out the segment. So we got to get rid of that because that's behind the rectangle. So we have to clip that out. So to do this, we need to determine 2 points. The point at which the line intersects the rectangle. Yeah, so once we find that line that intersects, then we can just project that onto the screen. So we get this point project onto the screen, so we have that point. Then the next point is the point at which the projected line intersects the bottom boundary of the projected rectangle. So in other words, we have to find this point, that's number 1, project it onto here, and then we got to find this point where the line intersects this bottom boundary, and now we have the 2 points and we can clip these out. So that is some fascinating stuff that we got to do. All right, so let's look at the first one. And this is why it's a discovery project. It's again, intense project. So point of intersection of the line and rectangle. So to determine the point of intersection of the line and rectangle, we first determine the equation of the plane. Whoops. All right, back here. So of the plane that contains the rectangle. So we got to find this the plane of this rectangle. So it's going to be something like this that contains this inside it. So we got to find that out. All right, so to do that, we just use the equation of a plane. So at P, this is going to be the normal vector dot product with the R minus R naught vector. This, and then set that equal to 0. So if we look at our rectangle, it's going to be something like this. Let's say rectangles like this. And all we need is several points. And it doesn't matter which ones we pick. So let's just take a look at, let's say the first point here. Let's take the first 3. So we'll take these ones, 621, negative 147, 206, and write that down here. I'm going to write it right here. In fact, this is actually the right location, but it doesn't matter which location because it's all on the same plane. So negative 147 and 206. Then this next point is going to be, let's put this 563 and 31. So we need 3 points actually, then 242. Yeah, 242, like that. Now let's just double check. So 563, 31, and then 242. And we have this, yeah, 563, 31, 242, and the next one, 657, negative 111, and then 86. All right, so put that here. This is going to be 657, negative 111, 86. So we have 3 points. It doesn't matter if these are in the same vertices. It doesn't matter because even if this is the actual one is over here, the lines are still going to be on the plane. All right, so what I'm going to do is now I'm going to get a vector here. I'm going to call this vector, let's call this vector A. Yeah, so let's say we have vector A. Then this vector here is B. All right, and now let's say we have a point here. Let's say we have, let's say we had the origin is somewhere inside the rectangle through it. So the origin is somewhere there. Let's just draw it through it here. Let's say it's somewhere across here is the origin, and we'll have dot, 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 like this, indicate it's a vector. Let's say this is the R naught vector, and then we have a generic one all the way up to here, and this is going to be the R vector like that, just for the x, y, z. So then the R naught is going to be this point right there. All right, so that's what we have. So we need to find the normal vector. So the normal vector, let's say the normal vector looks something like this, and this is going to be perpendicular to this, and the normal vector is going to be n. The normal vector is also perpendicular to the A and B, so that means we could solve them. Yeah, all right, and yes, it's parallel. I mean, it's perpendicular to it, and we could try to draw this. It looks something like this. So perpendicular to A, perpendicular to B as well. I'll just make that actually straighten up. All right, here, just fix that up to make it look actually more perpendicular. So there's the n vector. So the first thing to do is, well, we need to get the n vector. That's a cross product of A and B. And I'll write this on the other side so it's more visible, B. So let's find A and simplify it as before. So A is equal to, so this vector, I'm going to just speed up the calculations like before and put a bracket like this and put the subtraction here. So we're going to subtract this 563 from this vector, so 563, or this coordinate from that coordinate, to get a direction vector from here to there. Yeah, or a difference vector, but here notice that we're subtracting a bigger number from a smaller number, so that means this has to be in the negative side. So 563 minus 621 is going to be written like this. Put a negative here and put a 621 minus 563. So we'll have it on the reverse, but then make it a negative sign. So this is going to be 11. And this is going to be a, that's going to be 11, so this is going to be a 1. Then this is less than that, so we'll put a 1 and then take this out and put it as a 5. All right, so 11 minus 3 is going to be 8. So 8, and then 11 minus 6 is going to be 5. So negative 58, and this 5 minus 5 is 0, so it's going to be negative 58. Now the next part is going to be this 31 minus negative 147. So it's going to be 31 minus plus 147. It's going to be 871. And then the next one is 242 minus 206. So 242 minus 206. And subtract this is going to be a 12. This is going to be a 3. And this is going to be 12 minus 6 is 6. And then 3 minus 0 is 3. 3, so 36. So that is what we have. And what I'm going to do here, actually, I'm just going to take out some factors. So I'm just going to take out 1/2. So this equals to 1/2. I'll leave this a negative in there just to make it getting a bit simpler. So 58 divided by 2. Yeah, so 2 goes into 5 twice, and we're going to have a 1 left over, 118. That's going to be, and then 2 goes into 9 times. So 29. Next one here, 178 divided by 2. So put in this. 2 goes into 17 8 times, remainder 1, and then there's a 18, 9. So yes, if you like my fast long division, right, or long multiplication, long division. So now take a half from 36. 1 goes into 3 once, then there's a remainder 1, and then 1, then 2 goes into 16 8 times. All right, so we have that, and let's just choose the simpler one. Choose A, just this vector to be equals to negative 29, 89, and 18, because we don't care about the magnitude. All right, now the next one is, well, let's find the B vector. This equals 2, and we're going to do the same setup. All right, so the B vector is right over here. So we're going to subtract this one, this subtract from this. So 657 minus 621, etc. So this is going to be 657 minus 621. I believe that's what it was. Yeah, 657 minus 621. That's going to be 7 minus 1 is going to be equals 2. It goes to 6. And then 5 minus 2 is 3. And this is 0. 6 minus 6 is 0. The next one is, right here. Negative 111 minus 147. So that's going to be a plus. So we'll just do negative 111 and then plus, plus 147. So this is the same thing as writing 147 minus 111. So let's move this on the other side. So the same thing as 147 minus 111. Let's do that. So 7 minus 1 is 6. 4 minus 1 is 3. And then this 1 minus 1 is 0. So leave that like that. And then the last one, 86 minus 206. So that's the same thing as writing 206, put a negative, minus 86, like that. So it goes negative, 6 minus 6 is 0. This is 10, this is 2, this becomes 120. All right, so that's 120, and then let's simplify this, remove a 1/2. So 36 divided by 2 is 18. And then we have another 18, and 120 is going to be negative 60. So we could take out another 2. So this equals to 1/4. This is going to be 9, and 9, and then negative 60 divided by 2 is negative 30. Yeah. And we can keep going. We can take a factor out of 3 now. So 1/4 times 3 is 1/12. This is going to be now 3, 3, and then this is going to be negative 10. So we'll just choose a simpler one. Choose B vector equals to 33, 3, negative 10, like that. All right, so thus we have the n vector is going to equal to A cross B. So this equals to the I, J, K, and then plug this all inside. And this is going to be, well, the B one's going to bottom 3, 3, negative 10. Then we have the A one is negative 29, 89, and 18. So negative 29, 89, and 18. Negative 29, 89, and 18. All right, so now let's do the cross products. The first one, we cross out this, and I'll put this like this, cross that out. And this equals 2. Then put this like this. This is going to be, now we multiply 89 times 10, negative 10, negative 890, and then minus by 18 times 3. All right, and this is going to be the I. And the next one's going to be plus. Get rid of this, put it like this, and now we're going to go, actually it's going to be minus. The middle one's a minus. So minus, and then negative 29 times negative 10. That's going to be plus 29, 0, minus 18 times 3. Like that, and I'm going to shift this over. Right here, I just shifted it over. I mean, this is J, and then plus. That's a plus, and then do the same thing for the last one. This is a 3. Cross like that. Put a bracket. This is going to be negative 29 times 3. Minus 89 times 3. And this is K, like that. Alright, so that's what we have now. And let's continue with our journey of manual multiplication. So this one, 18 times 4, I mean times 3. 18 times 3 is equal to, so 3 times 8 is 24, put a 2, is 3 times 3, 3 times 1 is 3, plus 2 is 54. So then this means negative 890 minus 54. And since we're both, these are both negative, it's the same thing as adding them up. So what I'll do is, to avoid confusion, I'll put this in bracket, put a negative, and put a plus like this. So we add them up. So this becomes 4. 9 plus 5 is going to be 14. Carry the 1, so 9, 4, 4. And then put the negative down. So we have this negative down there. So it's going to be negative 9, 5, 4. Negative 9, 4, 4. And what I'll do is, well, actually, we'll do that one after. So this is going to be equal to, we'll do that later. So the next one here, this is just going to be 290 minus, this is going to be 54. So 18 times 3 is 54. 54, this is going to be now, this is 10. This comes 8. So 10 minus 4 is 6. 8 minus 5 is 3. And then 2, 3, 6. And then lastly here, yeah, so here we have multiple stuff here. So this is going to be negative 29 times 3. This is, let's go 29 times 3. All right, times it by, I'll put a negative just for completeness. So negative 29. So 3 times 9 is 27. 2, carry the 2, and then 3 times 2 is 6. So 87, like that, or negative 87. And lastly here, this is subtracted by 89 times 3. This is going to be 3 times 9 is 27. Carry the 2. 3 times 8 is 24, 26. Alright, so then when we subtract these, it's the same thing as writing negative. This is going to be 87 plus, so negative 87 minus 267. That's going to be the same thing as writing 87 plus. Let's move this here. Yeah, it's 87 plus 267 and put a negative, so this is going to be 8, 7. Yeah, so 7 plus 7. Oh, it's not writing. Okay, 7 plus 7 is 14. Carry the 1, 8 is going to 9. Plus 6 is 15. So 1, put a 1. It's going to be 3. So negative 354. All right, so then what we get is, finally this equals 2, and write it in the triangle bracket format. So negative 944. Now this one is 236, but there's a negative at the top there, so negative 236. And then lastly, this is going to be negative 354. So this is the normal vector. And now we could factor this out further. Well, I'm not going to explain how I did it. So I just did it with a calculator. If you take out negative 118, what this becomes is this goes into this actually 8 times. And this one goes in twice. And this one goes in 3 times. So we'll have 8, 2, 3. And then we'll do a calculation check later. I just want to get rid of that. I do not want to do more calculations with these giant numbers. So we're going to choose the n vector equals 2, the simple one, 8, 2, 3, like that. All right, so this means then that, thus what we have is the plane, the equation of plane is going to be n vector dot product with r minus r naught equals to 0. So this means this is going to be written as 8, 2, 3. The dot product of is x minus, and then the r naught vector. So again, recall we chose r naught to be this one, 621, negative 147, and 206. So this is going to be 621, and then this is going to be, the next one is be y minus, and then y minus 147, actually minus plus 147. So minus negative 147, so that's going to be plus 147, and then the last one, is going to be z minus 206. This equals to 0, and just to double check, 206. So yeah, 621, negative 147, 206. 621, negative 147, and 206, and then multiply these inside. We get 8x. So I'll multiply this inside the other ones later, but I'm going to go 8x. All right, so that's 8x, and then this one's 2 times, dot product just multiply corresponding, the corresponding coordinates. So 2 times y plus 147. So we'll just do the y plus 2y. So 8x plus 2y plus 3z. And then now what I'm going to do is I'm going to multiply each one inside. So 8 times negative 621, and then move it over to this side. So what we'll have is here, I'm going to write this as well, 621, and actually what I'm going to do is move it down a bit, so put the 621 like that, and yeah, so then we'll have it multiplied by 8, so times by 8, this equals to 8 times 1 is 8, then 8 times 2 is 16, carry the 1, 8 times 6, I think that is 48, then 49, 49, yeah, so 4968. And then the next one is going to be 2 times 147. So this is going to be plus, and then this is going to be 147 times by 2. This equals 2. Well, 2 times 7 is 14. Carry the 1. 2 times 4 is 8. Add the 1 is 9. And 2 times 1 is 2. 294. Next one. Yeah, because we made a mistake because we moved this over. So this is a plus, but we moved it over. This is going to be a minus now. So this is going to be a minus. Yes, minus 294. The next one is going to be, well, not a plus. Yeah, actually, it is a plus. It's a negative. We move it over to this side. It becomes a plus. So it's going to be plus 206 multiplied by 3. And then times it by 3. This is going to equal to 3 times 6 is 18. Carry the 1. 3 times 3 is 0. Add the 1. 3 times 2 is 6. So 618. So yes, just bear with me. I kind of like doing the manual calculations. It's a good mental workout. So for the next one, 4. Let's put this like this, actually. 4968 minus, let's go 294. This is going to be, well, subtract 8 minus 4 is 4. This is 16. This becomes 8. 16 minus 9 is 7. 8 minus 2 is 6. This is going to be 4 minus 0 is 4. So 4674. And the next one, plus 618. Plus 618. So 8 plus 4 is 12. add the 1, and it's going to be 1, this is 18, 9. Yeah, so 7 plus 1 plus 1. Then the next one is 12, carry the 1, and it's going to be 5. 5, 2, 9, 2. Alright, so that means our equation of a plane is, I'll write P, it's going to be 8x plus 2y plus 3z equals to 5292. Absolutely remarkable stuff like that. This is the equation of the plane that contains the rectangle. I'll move this down here. Or let's move it down a bit like this, all of it together, and box that. Actually, we don't have to box that. We box this whole thing in like that. So there's the equation of a plane. All right, now that we have this, let's do a quick calculation check. So with GeoGebra, you can actually do a cross product, and you could, again, find the equation of a plane just by putting in the rectangle. So here's the cross product. So we go -2, 9, and then 89, 18. A cross product with 3, 3, -10. We get -944, -236, and -354. And that is right over here, -944, -236, -354. And then here I just simplified it somehow beyond even GeoGebra. GeoGebra doesn't even simplify it. And now if you go here, rectangle. Yeah, so here I just put the plane, put the rectangle inside. You get the automatically calculates the plane. So 8x plus 2y plus 3z equals 5292. So that's right here, 8x 2y plus 3z equals 5292. And then also here, like I factored out the 118. So 118 you get 823. So we take this 944 divided by 118 gets 8. Use built-in calculators, put a space equals, and we get 8 like that. Then 236 divided by 118 is 2, and there's the 3 right there. And lastly, this big giant calculation here, 4968 minus 294 plus 618, and we'll also with the multiplication. So 621 times 8 minus 147 times 2, and 206 times 3. So we have that all in here, 621 times 8, and space, 5292. So yeah, we can just put that whole thing in and solve it. Anyways, so now we can plug in our parametric equations of the line into the equation of the plane for the rectangle to get the point where they intersect. Now here I had copied and pasted. This was our equation of a line from earlier. Alright, so that's our line, and now our P, or our plane, is going to be this 8x plus 2y plus 3z equals 5292. So let's plug those inside. So this is going to be 8, and then the x, so yes, 823. So 8, plug in the 230 plus 630t, so plug this inside. Yes, let's plug that in. Yeah, let's put the arrow like that. Let's plug that in. The next one's going to be 2, and yeah, so 2y, 3z, so 2, -285 plus 390t, and then plus 3. Is it a plus? Yes, plus 3z. 102 plus 162t. This equals 2. Yeah, let's move this everything over. 5292. Let's make sure it fits into the box. Alright, now we have all this, and what I'm going to do is, well, I'm not going to do manual calculations for these ones. These are a bit too much, and we've done enough. So what I'll do is multiply everything inside and then do it by hand. No, I mean do it by a calculator. So 8 times, do the t's first. 8 times 630, and I'm also going to collect like terms as well. So I'll put a bracket right here. So 8 times 630 plus 2 times 390. So 2 times 390. And then the next one's going to be 3 times 162. 3 times 162, put a t. And I'm going to do now equals to 5292. And now I'm going to subtract, because I'm going to move all this to the other side. So this 8 times 230, 230. 8 times 230 plus 2 times, this is going to be -285. So I'll just put a negative there. So so the -285, and then plus 3, 102. Plus 3 times 102. Put a bracket. All right. So if you plug this all into the calculator, you get this one's going to be 6306, and this already here is going to be 3, and then this is 716. Then solve for t. We get, well, let's put the for completeness, we get a 6306t equals to 3716. So that means t is going to be equal to, and this is going to be 3716 over 6306. Plug into the calculator, you're going to get a 0.0, and this is going to look like 59 around there. I'll just block this out. Yeah, so that's our parameter t. Alright, so now that we have that, let's do a calculation check. So we'll have this 8 times 630 plus 2 times 390 plus 3 times 162. And we get this right here, space, 6306. And then lastly, or next up is 5292 minus 8 times 230 minus 2 times 285, and then 3 times 102. Put that all in there, 3716. And then divide these out. This equals to that. And then we get this 3, and then also if you divide this by 2, you can also factor it even further because they're both factors of 2. 3716 divided by 2 is 1815, and this one is 3153. And then if you divide these out, you get the exact same thing. But anyways, so the next step is you can also use Wolfram alpha. So you can just go solve for t, 8 times 230 plus 630t plus 2 times negative 285 plus 390t, etc. Throw that in there and it automatically solves it. Absolutely ridiculous. Right, so automatically solves it. T equals 1858, and then divided by 3153. So exactly this. Alright, so epic stuff. So plugging in the value of t inside the parametric equations of the line, we get, so 230, so x is 230 plus 630 times 185, 8 divided by 313, we get the 601, etc. The next one is negative 55.18, and the next one is for the z, 197.4634. And this point projects onto the screen and then we use the same equations. Yeah, same ones as before. So the x goes to the 0, it's on the screen, and then the y prime on the projection, we take this point and then divide it by 1 minus, and then the x coordinate of it. This x coordinate divided by 1,000. So like that 1 minus x coordinate divided by 1,000, we get this number over here. So again, built-in calculator. And then the same thing for the z, we take this number divided by 1 minus, and then x divided by 1,000, we get this 49.205. And then graphing this out in GeoGebra, as well as using the built-in calculations, the calculators or calculation checks. So we could do an intersection check right here. So this is our intersection. It's going to be this point, 601, 246, etc., and then negative 55, then 197.46, etc. So here's the point I put in manually. I put this one manually in. Now here, what you could do is you could do a rectangle plane, so that one we had, you could just use the intersect formula. So intersect, and then add the line L and the rectangle plane, and it automatically solves exactly this. It's exactly the same thing. But this one I rounded up 197.5. This is 197.46. So epic stuff. And then here's the intersection projection is going to be just this point, 0, negative 138, 495, etc. So we have that. And this projection line is from this point up to this point, I believe. Or, yeah, something like that, yeah. But anyway, so this is how this stuff looks like. So there's the intersection point right here. There it is on the screen. And now we have to find this point to get rid of this line behind it, so that it gives the illusion of 3D, or the perspective of 3D. And here, let's go back to the GeoGebra. So let's see what we have. Sightline checking. That's this one. And what I'm going to do is let's find the point. So intersection check. So this is intersection, like that. So there's the intersection on it. Let's see if we can get this look nicer going through it. All right, I'll just move things around. Yeah, there it is. All right, so there's the line through it. There's the intersection point, and let's see the projection. Intersection projection is somewhere there. All right, and now the only thing we need to do is actually we need to do a check, intersection sight line checking. So what I'll do here is we'll go from the camera up to intersection projection. So we could copy this and then block out this one just to make sure it goes through it. Intersection projection. Let's see if it shows. Yeah, so there it is. So this is from this point, and I have it graphed out all the way to this point. And as you can see, it goes straight through the rectangle point. So the point of intersection of the rectangle. Even though we're not graphing it we're graphing from here to here, and it cuts through, so that's a good double check of our work. Epic, epic stuff. Let's move this like this. And now the next section of this book, or of this problem. Alright, and now let's find the point of intersection of the projected line and the projected rectangle. So that's this point right there. So basically this part right here. Yeah, so like right there where it crosses, and this is the bottom part of the rectangle, and there's the line it crosses somewhere here. So we've got to find that point, and then we're going to remove that whole section from it. So from the above image, the projected line intersects the bottom right portion of the projected rectangle. So this is the bottom right there. I'm just going to call that bottom right. So recall the vector equation of the projected line we calculated earlier. So that's this equation right here. This is the projected line PL like that. And this was our vector equals to the this vector 0, negative 71.43, 600, and then plus t times 0, negative 328.57, and minus 514.29. And that is the parallel vector. We could scroll all the way up to find that. Let's just keep going. And here, yeah, I just teleported right here. So this is from I think that was question 3. Actually, it was question 2 when we projected it on using these projection 3D to 2D equations, and we got this part right here. So 0, negative 71.43, etc. And this is for the value of t is from 0 to 1, just basically going from starting point to the end point. And we get it starting from here and there. So that's the equation of the projected line. All right, and now that we have that line, and now recall the coordinates of the projected rectangle, and I'll call this R1. This is equal to 0, then negative 387.86, etc., 543. And there's the R2, R3, R4. I'll show you what they mean. Basically, R1, I call it the top one. This is R2, and then this is R3, and this is going to be R4. And we can see this if we go to the calculator right here. So there is the R1. So there's the dot. If you click this, whoops, move this around. So there's the projected rectangle. Click this shape. I don't know what's behind. Whoops. Let's undo. Yeah, so if you click that, and it highlights where we're at. So that's R1. Then if you click this one, it highlights R2 and so on. And you could just hide it. So R3 is here. And this is 0, negative 323.62, and then 250.73. There is R4, that's 0, 167, 0.08, and then 304.24. So that's this bottom one there. You gotta go through to see it. Okay, there it is. All right, so that is the bottom. So we just need to look at here. So we need to get an equation of a line from the bottom. We'll call this R3, and then there's the R4. So we got to get this line segment equation there. All right, so let's get back to here. So let's calculate the vector equation of the bottom right portion of the projected rectangle. All right, so to do this, to calculate it, let's do this. I'm going to go, let's just draw it out for completeness. So it's going to look something like this. This is going to be our R3. This is our R4. So that's all we need. And then this one, let's say we had, so let's say the origin is somewhere there. And it's going to be just through it. It's going to go across here. This is going to be R naught. And let's say that's R naught, and this is going to R1. And yeah, and then basically the line is going to be the vector pointing anywhere on the line. Let's call that R. And now instead of using T, we'll call it S. We'll use an S for it. So R vector equals to R naught. And then this is going to be plus S times it by V. So remember the V vector is a parallel vector. That's just going to be parallel to here and here. So that's the V, and the V is just going to be equal to R naught plus S times it by V is just going to be subtract 2 vectors. R1 minus R naught. Yeah, just get a difference vector. So this equals 2. Let's put this all together. This is the R naught vector is going to be just the R3. So 0, 0, negative 3, 2, 3. And then, 0.62. 0.62. and then the next one is 250.73, like that. And here, actually, I just erased it. I just paused the video and erased it, just typed it out to save time. So actually, yeah, let's type this out to save time. So R vector right here is going to equal to the R naught. R naught is going to be the R3. So that's just a 0, negative 3, 2, 3.62, etc., 250. And then plus, then we're going to subtract these. So S times, so we're going to go 0 minus 0, then 167.08. So this one minus this, and this minus this. And this one, you can have a built-in calculator here. One note, press space equals to 490.7. Yeah, so that is a calculation that's checked. And then this one here, we can go equals, and then 53.51. And that's exactly what we have here. So there is our vector equation of the bottom right part of this rectangle, or projected like rectangle. And yeah, it's projected rectangle. That's why the shape is not actually rectangle. Yeah, the shape is actually going backwards like that because it's projected on there. So it has to look like it's in 3D. All right. And yeah, just for completeness, let's make this look like how it looks like here. Yeah, it's bent on the other side. So let's just go bend it like that. So it looks something like that. All right, just fix that up. All right, now let's continue further. So if the lines intersect, then we should be able to obtain values of the parameters t and s such that the coordinates equal for each line. So basically, these need to be equal. So the y components, if you write in parametric form, this 40.97 times s, and then this minus 323.67. That equation needs to equal to this, negative 71.43, and this part right there. Yeah, multiplied by t. All right, then what I've done here is just typed it out just because there's a whole bunch of numbers to handwrite. That would be very tedious and long. So basically, the x coordinates for both of these are equal to 0. So x equals 0, x equals 0. And there's a 0t and 0s right there. Now the y, we need to set these equal. So negative 71.43, that's from the line. And then we're going to have to do subtract minus t times 328.57. So minus 328.57 has to equal to the coordinate on the rectangle line. So negative 323 right here plus 490.7 times s. So that's one. We have to equate it. Now we can simplify this further by moving this. Yeah, so we can move this over to this side. So we're going to have a negative 71.43 and then plus 323.67. And then if you put in the calculator here, this equals to 252.19. So that's what this equals to. All right. And then what we could do is divide everything out by 490.7. Yeah, so we could start dividing this all out. And when you divide it, you're going to divide this out. This equals to 0.5139. That's this right here. And then this one, let's erase this. And then this one right here equals 0.6696. That's this right here. So that's equation 1. So we'll call that equation 1. Then we can do the same thing for the z. So we'll have two equations, and then we can cancel out the s, and so on. So the second equation is we're going to have 600. That's the line right here. So 600 for the z. And then minus 514.29 for the t. Times it by t. So that's this right here. 600 minus 514.29 t has to equal to the right side of this. This is going to equal to the rectangle. So 250.73 plus s times 53.51. All right, and then basically doing the same thing. So we're going to take this this 250, move it over to this side. So we'll have 600 minus 250.73, and then plug in this calculator. This equals to 349.27. So that's this right here. And then we're just gonna going to divide everything out by 53.57 to just get s by itself, just like this one. So do that, and then divide this out. This equals to 6.5272, and that's this right here. And then last one here, this one here divided out by 53.51. Let's put in the calculator, and then put it like this. Equals 9.611, etc. So that just rounded up to 11. That's interesting. Let's put a 1 as well. Let's do that again. All right, so we have an extra 1 there. Interesting. All right. All right, and basically call that equation 2. So this is equation 2, and just make it look like it's not actually, yeah, it's not a subtractant from equation 2. This is a arrow. So that's going to be equation 1. That's equation 2. So subtracting equation 2 from equation 1, we can thus solve for t. Basically, when we subtract this from this, we cancel out the s's. So we do that directly. So this 0.5139 minus 6.5272 equals, this part is negative 6.0133. So that's that one. And then likewise, this this negative 0.6696, that is right over here. Yeah, negative that, and then we're going to subtract. Yeah, we're going to subtract the negative number 9.611, so that becomes positive, and then put this in the calculator. This equals to 8.9415. Actually, because I had these calculated with the just 2 ones. Now there's an extra one. All right. Whoops. So that's 1.5, and yeah, let's erase this now. Yeah, so that's what we have. So this becomes this, t equals 0, and then you can move this over, and then move this over to this side, and then divide it out by this to solve for t. So t equals to, it's going to be positive, divided by this, 6.0133 divided by 8.9414. It's actually going to be, yeah, it's actually, yeah, that's it. Well, actually, no, it's not 1.4. This is 1.5. Yeah, I have to update everything because that extra 1 that I ignored earlier. All right. Yeah, but it's still the same thing. Yeah, 0.6725. So that is what t is equal to. So plugging this value of t into our earlier equation or equation 1 into either equation. Yeah, so I put that in. So into either equation 1 or 2 and solving for s, we get, so we have it over here. So s is equal to, and this is equation 1, that's this right here. So s equals to 0.15139 and minus 0.6696, and then just put that in, times it by t, which is here, because remember we have a t there. So, and then this equals to, and so equals to, yeah, 0.0636, like that. So that picks up. So plugging these values, we have t and s, into the 2 equations of the projected lines, we get, then we can get the coordinates. All right, so the projected line, the x coordinate is 0. Then the y is going to be, remember the line is going to be negative 71.43, and then minus 328.57 times t. So plug in t for that. Again, let's just go look at the equation of the line earlier. So there it is, negative 71.43 plus t, and then you have these negative 328.57, etc. And that is right here, negative 328.57 times this by, and we get this number here. And yeah, so we get, yeah, these are the coordinates. Let's delete this. All right, and this is negative 292.3933. And likewise for the z, you get 600 minus 514.29 times it by t. This equals to, yeah, 254.14. And then you do that the same for the bottom right line of the rectangle. So then we'll call that x prime is going to be 0, x, and then y prime equals negative 323.62 plus 490.7 times by s. Put this in the calculator. This equals negative 292.4115. This one is 0.393, but it's pretty close because we have to round up on a lot of these. So because of the rounding, and each time you round it, you're going to have a slightly different answer there. Yeah, because we didn't use exact numbers. And again, this is the y prime, and that is just this part right here. This is the line of the bottom right line. So negative 323.62, and then there's plus s, 490.7. Just went to, yeah, 490.7. And then lastly for the z, projected the projected bottom right line of the rectangle, put in the value for s inside. So we get this number 254.133. All right, and this one is pretty close to this one. Again, there's some rounding errors, but it's, yes, identical. Almost identical. But then you can do a calculation check with Wolfram Alpha, and you can literally just type in, solve for two variables now instead of just one. So solve for s and t, so negative 71.43 minus 328.57, t equals to negative 323.62 plus 490.7 s, and that is this first equation set up here for 90.s. So that one, you can plug that one in and this one. 600 minus 514.29, so 600 minus 514.29. T equals 250.73 plus 53.51 S. So plug all that in and it automatically solves it for you. Unbelievable. So S is approximately equal to 0.06363. And then this one has more decimal places. So ours stopped at this one 0.0636, but then there's another 3 there for it. And then the T is approximately equal to 0.67251. And ours, this calculator built in OneNote just stops at 0.625. All right, so yes, it's a pretty epic Wolfram Alpha. Has more precision decimal places, and it does it automatically. And you could use human language like solve for S and T, and and you could use a number, just the word and does it all for you. All right, so we have all that, and it's pretty epic. So now graphing it all out in GeoGebra 3D graphing calculator, we get, so graphing this out in GeoGebra and hiding the line segment projected behind the screen, we have our final projected image. All right, so what we have here, if we scroll down, we have this part right here. Here's the rectangle bottom right line, and you could just literally just type projection R3. So those are the R3 that we had, and R4, and we get our equation of a line. So it's again built-in calculator. So we have the R naught is going to be 0, negative 323.62, and then 250.73. And they use lambda, but we just used S. And this is 0, 490.7, and then 53.51. That's exactly what we had, and you can see that here. So it's going to be 490, and then 490.7, and then there's a 53.1, and then this is the R naught values is 0, negative 323.62, 250.73. So yeah, 0, and then there's a 323.62, and there's the 250.73. Yeah, so it automatically solves it for us, and that is right. So we got the right line. And then what you can do is intersection, projection, projected lines, check. Yeah, so we could just plug this in. Instead of putting our values, we'll just go intersect the bottom right line and our projected line that we had earlier. It automatically solves it, and it gives it as 0, negative 292.4, and 24.13. So remember the negative 292. Yeah, so there's a negative 292.4, then 254.13. Yeah, 0.4 and 13, so exactly. So you get this exactly right. Epic stuff here. So what we could do then is in projected line screen, we could do a segment from the projected line 2. I mean, yeah, I think it's from here. So never mind, that's projected 1. We can do a line segment from here, the bottom, up to here. So we can go from here up to this intersection there. So we can go projection 2 and up to intersection projected lines, check. That's this one right here. So I just use those long ones. And then, so we do that, and then we can hide. And so we'll do a line from there and get rid of the line behind it, so we can remove this whole section and have a 3D shape, which will look quite amazing. And there is our 3D shape there. So there is the shape going through and projected on there, and we have a 3D image. Absolutely amazing stuff here. And let's go back to our calculator and see this all. So let's click it here, projected line behind the screen. So that's behind the screen. Projected lines check, that's over there. And there's the rectangle. Let's click this thingy so we can hide it. So let's hide the whole line. So that's the line, projected line. Let's get rid of it. All right, so we got rid of that. Now what we need is, yeah, intersection lines check. We'll put this here. There's a bottom right line here. So this bottom right line going through the rectangle there. And now what we need is projected lines. Yeah, there's the top. So there's our 3D image there. And if you get rid of these dots, you can see our line. So there it goes through the rectangle, and there is a 3D image going through that. Absolutely amazing stuff there. So yes, there's our 3D perspective on a 2D screen from the camera. So epic stuff.